So for today, would you compare these two polynomials? One of them has, well, it looks like they're very similar. What is different about it? What do you see?
Third area has a square.
And do you know what that would be called? The squared would make a what in the graph? I'll give you a hint. There's pass-throughs, snakes, and bounces.
Oh, a bounce.
It would make a bounce. Is that the only difference then? It seems like it's the only difference, but the thing is, now this one's going to be a different degree than this one is. Do you get what I mean by that? Would you please find the lead term, because that's what separates the A's from the B's. When people try to just graph this without the lead term, they're going to go, okay, it touches at 8, it touches at -5, and touches at 1/2. But they won't catch that it's up on one end and down on the other end. Because this one is degree 1, 2, 3. Its lead term is y equals 2x to the third, whereas this one is degree 1, 2, 3, 4, and so it's y equals 2x to the fourth. Do you get one of these? The ends go opposite directions, and the other one, the ends go the same direction. All right, now I'd like you to sketch both. Sketch both. Yeah, it hits at 8. They both hit at 8. They both hit at -5. But they're going to really look completely different. If you have trouble with this kind, it's just 2x minus 1 equals 0, and then solve it. Plus 1, plus 1. All right, I'm going to pause for a minute. When you're done, you're going to know which way they end. You know how hot, like on the right side, is it going up or down? On the left side, is it going up or down? It's got to bounce somewhere on one of them. All right, pausing. -5, 1/2, and 8. But this one goes opposite directions on each end. Since they're both positive in the front, they both go up on the right, and then I should write out bounce by the one that bounces. The only one that bounces is because of that squared. It's called its multiplicity, and that means there's a bounce right here, and I put a B for bounce. Okay, so then I can just cut through all the other ones. There we go. And this one. Bouncing there, going back up. You know, the difference is right here. Because they were darn close to the same, except on the right-hand side of the graph. On this one, it was forced to bounce, which made it go up at the end. This one didn't bounce, so it went down at the end. So that's the difference. Okay. Just make sure you get all of those words. You good with all those words? So lead coefficient is just the number in the front. The degree, it's the biggest power. That whole thing's a polynomial, but I could have called it a trinomial. Yes?
When graphing that, should we have found the y-intercept to kind of
Good question. It does depend on the problem. Sometimes the numbers are going to be small enough that you can stick in x equals 0 and find the y-intercept. This one, the y-intercept would be easy. I could just put in a 0, put in a 0, put in a 0, and then y equals 0. And I know it touches at 0 on this one. But the other one, I don't know if the numbers were big enough or too big. So that's what I've found. Sometimes we'll ask you for that, sometimes we won't. Depends on how big the numbers are. All right, everybody go to this page. We can figure out our end behavior and x-intercepts to create a pretty good sketch. I feel like this is complete review. You should be able to graph this. In a moment, I'm going to ask you to compare your answer to the kid next to you. First, find the leading term from this, this, and this, and put it right here. I don't care if you do this because you're going to be putting it on the graph. So find the leading term and then just graph it. And in a moment, I'm going to have you compare with the kid next to you. Make sure you get this. I'll pause to give you some time to work. Good. So we figured out the lead term is 2x to the third. That's positive, so we're going up on the right and down on the left. Very good. And since there wasn't any bounces, why? Because there wasn't any like squareds here, then we just passed through them all. If you haven't already, make your graph pass through those three things and you'll have it. There you go. Raise your hand if you did that one right. Awesome. Now, how could we make it just a smidge harder? Find the what? What didn't I ask for yet, but I could? Yes?
Y-intercept.
The y-intercept. Now go back to this, and everybody take just a heartbeat here and go, okay, what would happen if I stuck in x equals 0? Find the y-intercept. It's where x equals 0. So that cancels, that cancels, that cancels. Don't forget this is multiply. Did you get 3 times 1 times 2, but it's negative, so it's -6. Raise your hand if you had -6. Excellent. And so that could have been on the test, because that's doable. If the y-intercepts are ever just like awful, like, you know, -60 or whatever, obviously we won't ask you for that. But if it's -6, yeah, that could happen. Now it's even more accurate. Do you get this? That's what the test is like. One more. One more. Try this one. And Alexis, could you shut that door for us, please? Thank you. Eddie, for future reference, you're going to get in trouble if your friends yell into my room, just so you know. Not good. All I'm asking is that you tell them to knock it off. All right. -2 is definitely a thing. +1 is. I'm going to set this one up because I was afraid I was going to screw up the fraction. It's got a negative in it. I almost did screw up the fraction. It's that -3/2 again, which is -1.5. These are annoying. They're all so close to each other. Oh, for Pete's sakes. I didn't even notice. All they did was the same problem, except they asked you for the y-intercept, which is what we just did a second ago. I apologize. It's the same exact graph. That's why it looks so much alike. They just want the y-intercept now. All right. Okay, this one. Last one, I promise. If you all try this one. Can't ask you to be perfect, but I can ask you to try. Everyone give this a shot. So we're going to start with one of the students figured out that the leading term was -x to the 6th. And that tells me the right end. It also tells me the left end is going up or down. The only thing I don't know from this is the y-intercept. And this time it specifically says what's the y-intercept. So make sure you include that. This would be like the hardest graphing question on the test. Okay, so be really careful. Where does it bounce? Where does it snake? Where does it just pass through? Where does it have a y-intercept? Is it up or down on the right? Is it up or down on the left? Prove to yourself that you can do even the hardest one. Graph.
They're like the two ends are both down.
They're both down. It's got a degree 6. Yeah, I agree. They both have to be something. And the negative here tells me it's down on the right, and they both have to be the same because this is even. I agree with you. Nice job. Next, Mr. Humphrey, tell me, what's one of the roots? How about this? What's the root where it's bouncing?
Oh, like the point,
Yep.
-1.
No, the bounce here, this and this aren't bouncing. I'll circle it in blue here. It's this one that bounces. Be-
It's -2.
Close. You always never trust the inside. +2. +2.
Don't you have to distribute the negative on the outside?
I get what you're saying, but that doesn't affect where the root is. That negative on the outside actually only tells us that the right side is down. So it's not going to change your answer. I understand now how you got it, though, so that's good. But nope, the answer is +2. Because really what it's about is what makes this equation 0. Do you get if I put a +2 right here?
Yeah.
It would be 0. And then what's -0? It's still 0.
Yeah, okay.
So it's +2. It's bouncing there. And there's also this +1. I hate that they're all clumped up. But the reason is because they wanted you to find the y-intercept. So they had to use really small numbers. And last, I understand, is -1. And that one's a snake. I'm going to put SN for snake. And now here I go. Bounce. Pass through unless it's something special. This one says snake, so I'm going to try to do a snake. So I'll just go back and label it as snake. And that'll be, teacher will be okay with that. Snake. You don't have to label a bounce because it'll be obvious that it's bouncing there. So I can get rid of this word bounce here, but there you go. Is it a perfect graph? No. In fact, one thing I asked you to figure out was the y-intercept. The not the x-intercept, the y-intercept. Finish this sentence for me. The y-intercept is where x... Stella, do you know the answer to that? The y-intercept is where x becomes 0. Good. So I'm putting in an x is 0 right here, here, and here. Everybody figure out what you think the final answer is to that. That's +4. Wait, but there's a negative there. That makes it -4 times -1, which is +4, times 1 to the third, which is just 1. So then it's +4. Raise your hand if you add 4 before I did. Okay, awesome. So the y-intercept's 4, so I should really graph it right now. And I'm put the 4 in the right spot. This goes through 1, 2, 3, 4 right there. And looky there. Yay. That is a typical hard test question. Any last questions? Yes.
Is it better to make the graph from like left to right or from right to left?
It does not matter. The thing I would focus on is make sure that you start either up or down like you're supposed to. And then it doesn't matter. Either way works. Personal preference. Okay, so there's a worksheet, but I also want you to know that I don't expect you to do all of the problems on the worksheet. So would you please open up the worksheet? We'll get it to be reasonably sized, just a few problems to practice. And then I'm going to do another day of calling kids up and fixing your most recent first 20. I'm going to help you fix a problem on it. I want to try to talk to everybody today, just briefly. on a problem you got wrong on your first 20 and try to get you one step closer to being awesome at that. Okay, do you have the worksheet pulled up yet? Okay. I'm gonna come over and pause for a second and look at it. We're gonna keep this one very reasonable. We're skipping the middle of it, which is problems 2 and 3. So just do problem 1 and problem 4. I encourage you to then, when I call you, you're gonna bring up your iPad and you're going to be showing me one problem you got wrong on that first 20, and we'll talk about it. And don't pick one that you just made a dumb mistake on. Pick one that you actually genuinely need me to show you how to do, okay? We're not gonna let this thing go until you all have at least close to an A on that thing. So if you have lots that you're getting wrong, take the time today and talk to me. We'll get it fixed. All right, that's all I have for you for today.